Bom dia, obrigado, Federico. Thank you for inviting me here to speak this couple of days. I'm honored to have been invited to come down to Rio de Janeiro. I'd like to thank the organizers, Sembra, the facility here for hosting us, the delegation that have attended from the Navy, the various universities and commercial enterprises here in Brazil. It really is a privilege for a commercial operator, a commercial manufacturer such as Kongsberg to come and tell you a little bit about the state-of-the-art technology in autonomous underwater vehicles. For those who don't know us, Kongsberg is a Norwegian company. We are owned, about 50% of it is owned by the Norwegian government. And we've been around for a long time. We've been around for 200 years. About 1 month ago, we celebrated our 200th anniversary. And we started off actually becoming the very, very first industrialized company in Norway. And our product line was very, very different from what you see today. We started off by making rifles and harpoon guns and odd pieces of equipment like that. We evolved over time though, and in the 1960s we started becoming involved in the underwater industry and building sonars and multi-beam echo sounders. And since then I think we've become renowned as perhaps the #1 provider of subsea systems. We operate in the same way across the world, and we collaborate with all of our customers. We work to innovate and develop new solutions to fit your individual requirements. And I think that's borne out by the successes we've had becoming the #1 subsea company in the world. Kongsberg Maritime is just one small group within the overall company. We're headquartered in Norway, but we have offices in 18 different countries. We've got over 50 offices now, including one here in Rio de Janeiro, where we have something like 100 field support engineers and a training facility. We have quite a large presence that's growing down here all of the time. Our product portfolio is not just underwater vehicles, so we build sensors, sonars, we build cranes and winches, we build pretty much anything you can imagine that goes under the water and the associated topside equipment. What I'm going to talk to you today though about is our operations or our manufacturing of our autonomous underwater vehicles. So Kongsberg Maritime builds vehicles in Norway. We build the Hugin and the Munin vehicles, but we also have a company called Hydroid based in the United States that's 100% owned by us, and another company called QT, Kongsberg Underwater Technology Incorporated, also in the United States, again a complete subsidiary of ours. So we build a range of vehicles that I'm going to talk to you a little bit about as we go forward, and I'm really going to concentrate on the absolute state of the art, the best that money can buy today in the world. So our AUV program was started in the early 1990s, actually quite late when you look at the industry as a whole. The first real AUV was developed back in 1957 by the University of Washington in Seattle, and it was called the SPURV program. So we were a latecomer to the game. If you consider International Submarine Engineering, the company that worked with Ifremer and that I used to work for as well, they developed their first AUV in 1983. So we were not the first, but we have subsequently become the largest by dollar value and by numbers sold, and also by number of kilometers covered by our vehicles. The REMUS program that we inherited when we bought Hydroid back in 2008, of course, was an academic program developed at Woods Hole Oceanographic Institute. Again, started in the early 1990s, but with some very different aims and different technologies. If you compare the two vehicles, the Hugin and the REMUS systems, we achieve similar results, but going quite different routes, and I'll talk a little bit about that as we move forward as well. In short, we've sold 40 Hugins. So 40 doesn't sound like very much, but of those 40 Hugins, they've covered more than 600,000 line kilometers of commercial survey around the world. There is no other manufacturer that gets anywhere near that. From the REMUS side, they've built over 300 vehicles now. So if you consider that the entire AUV marketplace, academic, defense, and commercial right now stands at something like 780 to 800 vehicles globally, including little project vehicles built at universities right through to the full ocean depth AUVs, the 6,000 meter plus AUVs. We have actually built almost half of all of the vehicles that are now available in the world. So the products that come out of Kongsberg Maritime, we have three main ones. The top bit of the picture here is relatively new to us, and this is QT, Kongsberg Underwater Technology Inc., based in Linwood, Seattle, and they build and they sell the Sea Glider. So this vehicle was originally developed by the University of Washington, and it is a traditional oceanographic glider. So it can carry small power load payload sensors such as ADCPs or hydrophones and oceanographic sensors. However, it can go a very, very, very long way. Endurance of up to 10 months is quite possible with these vehicles. The vehicle in the middle is Moonin. This is our latest commercial offering. So Moonin is built in Norway, and it combines some of the technology developed by Hydroid and some of the technology developed by Kongsberg Maritime to present a low logistics commercial solution. So this vehicle gives 24 hours endurance at 1,500 meter depth rating and carries side scan sonar, multi-beam echo sounder, sub-bottom profiler, camera, conductivity, temperature, depth, all of the usual things that you would expect in a commercial vehicle. It operates them all at the same time, so you get a complete data set from every dive. And it can do that for 24 hours at a time. Now you think 24 hours, if you compare that to some of the smaller vehicles, the Remus 100 that Peter mentioned earlier on, that in some configurations has a 6, 7, 8 hour endurance life, and we do this at 24 hours in a vehicle that's only 34 centimeter diameter, and it's only 4 meters long and weighs less than 300 kilograms. So we've packaged a lot of energy into this new product that we have. The one at the bottom is really what I'm going to concentrate on a lot of today, and that's the Hugin. So this really is the flagship commercial solution that's available today. We've sold 40 of these. We've delivered them to hydrographic offices, such as the Indian Navy Hydrographic Office. We've sold them to commercial survey companies, such as Fugro, CNC Technologies, DOF Subsea, Viconia, Northwest Maritime. There's a whole bunch of survey companies out there operating them. But it's also in operational service now with navies around the world. Royal Norwegian Navy, the Italian Navy, the Finnish Navy, to name but a few. And it has a variety of applications and operations. If you consider Hugin as the flagship, you'd think, well, how does it achieve 75 hours endurance with all of this payload on board? It's packed with lithium polymer, rechargeable or swappable batteries, so you can take them out between each dive and still have short on-deck turnaround time of less than 2 hours. Now, some things were mentioned yesterday about the cost of developing these programs. And I'm just going to throw a number out that actually comes directly from our Kongsberg management meetings. The Hugin program started in 1993 back in Norway as a joint program with Statoil, FFI, which is the Defense Research Lab in Norway, and Kongsberg. So Kongsberg alone, out of those three organizations, has invested over 500 million Norwegian kroner into this program. So 500 million Norwegian kroner is somewhere in the region of $80 million US invested into the Hugin program alone. So it's not a cheap development to actually get to the state-of-the-art, the most successful developed vehicle in the world. Some of the other vehicles we offer out of the Hydroid office in the United States are perhaps more known to the military operators, the very low logistics academic marketplace as well. The Remus 100 is by number of units the most successful vehicle ever manufactured. There's a couple of hundred of these vehicles out there right now. And they're very small. They're an 8-inch diameter tube that, as you saw from Peter's video earlier on, 2 people can lift over the side of a rigid inflatable and drop it in the water. It's a very flexible, very lightweight, portable, fast turnaround academic tool. To give you an idea of cost, if we just go back to some of these vehicles, if I start from the top, cost-wise, about $150,000 US for the glider, about $2.5 million US for the Moonin, up to about $5 million for the Hugin. But that's the whole system. That's the vehicle, the payload, the training, the spares, the support, the positioning equipment, the containers, the launch and recovery. So that's everything you need to operate. And we then jump forward to the Remus 100, and this is why it's so advantageous to smaller academic establishments with smaller budgets. So this vehicle starts at about $500,000 and can still achieve an awful lot. Vehicle in the middle is the Remus 600, so it's slightly bigger. You might, if I flip back again, notice a similarity between the Remus 600 and the Moonin vehicle. It uses the same body sections, but it has different software, different control architecture, different navigation equipment, and different payload options available. So Remus 600 is designed predominantly for the military market, and last year, for the very, very first time, Hydroid actually sold more Remus 600s than they did Remus 100s, which is a big change for them. And then at the very bottom, we've got the deepest AUV that we currently build, which is Remus 6000. All I'm going to say about the Remus 6000 is then there's not a lot out there. There's no real commercial requirement to have these vehicles at that sort of depth. It's incredibly capable. It'll go down to 6,000 meters and spend 18 hours at the bottom surveying side scan, multi-beam, or sub-bottom. But in effect, this vehicle at the bottom here is nothing more than a Remus 100 with a lot of syntactic foam wrapped around it. So as an academic tool, it will go a very long way and go very deep, but it's actually relatively cheap to buy and to operate. So that's a quick look at our portfolio. I promise the sales pitch is now over. I'm now going to talk to you about what they can do. So, commercial applications for AUVs. Many of you are probably very well aware of the standard hazard surveys, site inspection surveys, the traditional geophysical work that AUVs have been doing for many, many years. In fact, the very first commercial AUV survey conducted by Hugin was as long ago as 2000 by CNC Technologies. And since then, more and more and more applications have become accepted by operators. Recently, we've seen the introduction of geochemical survey and pipeline survey. Pipe inspection really is one of the big growth areas. I've got some nice little slides on pipeline survey coming up later on. Academically, pretty much the application portfolio for AUVs is limited only by the imagination of the scientists. They are used for oceanography, hydrography, technological development and test vehicles. One of the interesting projects that I've been involved with a few years ago was when I was working with ISE, and that was an UNCLOS survey. So the United Nations Convention on the Law of the Sea, and we took two vehicles up to the Arctic and put them underneath the ice and let them go off and survey completely autonomously the continental shelf in the Canadian Arctic. And that's perhaps, even to this day, one of the most challenging AUV missions that's ever been undertaken. For military operators, there's various phrases that are thrown around that don't necessarily make obvious sense to start with. So, mine countermeasures sounds like you're going to find a mine and blow it up. But mine countermeasures, when it comes to AUV operations, until very, very recently, has purely been detection. Classification and identification and destruction of those mines has always been done by a separate asset, sometimes an ROV, sometimes a little disposable mine vehicle, but quite a lot of the time still by divers. Now, things have changed in that environment recently, and one of the elements I'm going to talk about in the intelligent robots side of this presentation will concentrate on that. Rapid environmental monitoring is really just an assessment of the area in which you're going to operate in with an AUV or put a coastal patrol vessel into, or any environment prior to actually moving into it. And AUVs are an ideal tool for that because they are covert, they are quiet, they are difficult to detect, and they can go in and come back out very, very rapidly and collect a very comprehensive data set. So the data set really is what it's all about. Unfortunately, most of the AUV manufacturers, and there's about 10 of us in the world, unfortunately, we still concentrate on what color the platform is and how long the platform is and how deep it will go and how much it's going to cost you to buy from us, whereas really, I don't sell an AUV. I sell you guys a data set, and it's your data set that becomes your product. So it really is all about the data. It's To that end, we concentrate on productivity. So state of the art, as I mentioned earlier, Hugin, the most commercially successful vehicle, carries a whole bunch of payload sensors. And if we look at what's available today, so synthetic aperture sonar, which is an interferometric system providing bathymetry, will give you about 2.6 square kilometers per hour in data coverage. So HISAS gives you imagery, it gives you bathymetry, and the imagery really is quite phenomenal. If we have a look at this slide, this was taken by us just outside of our office in Horten in Norway. The submarine there, we've blown up, and if you look at the HISAS imagery, the resolution is as good as 2 by 2 centimeters with HISAS, and that's range independent, whether it's where the vehicle tracks or right out at 320 meters away where there's a 1 by 1 meter cube that's easy to see there. This was taken by VTD71, which is a German research lab, and they have a vehicle that has HISAS and a traditional side-scan sonar on it. It's a relatively high frequency, it's an 850 kilohertz side-scan sonar, and you can see from this sonar target, there's something there, but you can't really see what it is. And then we have the HISAS imagery of the same target on the right-hand side, showing how good the resolution is. Now, because it's interferometric and we get bathymetry from that, we can overlay, we can fuse that imagery with the bathymetric data. And you can quite clearly see here the various spheres on that target, and those spheres are 6 centimeter diameter steel balls. So the resolution of this really is the best that you can get on the market right now. HISAS bathymetry then goes across the entire swath, out to about 300 meters either side of the vehicle, and that's what gives the productivity, the data coverage. If we tie that in with the standard EM2040 bathymetry, EM2040 really has become the multi-beam of choice on the large commercial AUVs, then we have an even better data product for bathymetric survey. And it looks really nice, but with the EM2040 you also get water column data and you get an inspection multi-beam. So this particular picture was taken by CNC Technologies in the Gulf of Mexico late last year, shortly after they integrated an EM2040 onto one of their vehicles, the Sea Surveyor 4. And I think you'll agree it's a very, very nice piece of imagery. Whizzing through, we also do all of this together. So multi-beam, side scan, sub-bottom profiler, camera, it's all taken at the same time and it's all fused together so you get multiple data sets from the same vehicle. This, to give you an idea of how long we've been doing this, this was taken back in 2003, so it's not a new art form for us, it's very, very robust. And then recently, so we can do the pipe survey work, we've actually gone in and put some cameras on our vehicles. So we have a 10 megapixel black and white camera that's mounted on the Hugin and can take very, very nice imagery. This pipe is actually a 7 centimeter plastic water pipe that we do all of our surveying on, our trial surveying on. This image was given to us by Fugro very, very recently because they've started using these cameras now on a commercial basis. So the data looks really, really nice, very, very nice. I'm getting the hurry up now, so I'll speed up a tiny bit. The data looks very nice, but if you don't know where it is, it's kind of pointless. It has no value. So one of Kongsberg's core competencies is actually underwater navigation. So we have various tools and tricks with the Hugin and the Moonin and some of the Remus vehicles to get that position accuracy as good as we possibly can. So we have inertial navigation systems on the vehicle tied to a Doppler velocity log and aided externally using a USBL, an ultra-short baseline positioning system. We then can tie that in with some seafloor navigation, feature navigation techniques, and it means that we can have real-time position accuracy as good as 50 centimeters for the data that you're going to collect. What we like to provide is an AUV in a box. So we give a system. We don't give a vehicle. We don't sell a sensor. We give a system for people to operate. Commercially, this is the most common way of doing it. Academically, we sell platforms. We sell pickup trucks for guys to bolt on their own sensors and do their own stuff with. But commercially, an AUV in a box is the way to go. Now, very quickly, looking at the intelligence of these robots, we have an automated pipe tracking system on board our vehicles where the sensor collects the data and in real time processes the data. So we do a 2-track system, one along the side of the pipe using side scan and one over the head of the pipe using multi-beam and camera. The side scan will identify and follow the pipe and in real time show you the pipe give you the data, and tell you it's tracking it. It will create a map on board, and then it will return over the top using the multi-beam and track the pipe using that. Descend to very, very low altitude, 3 meters or so, to collect photographs of that pipe. We've used this system on trials and demonstrations, and actually it's been commercially operated now in the west coast of Africa, and it is about to start work here on a Petrobras contract in something like 2 months' time, on a very, very long and challenging contract down here. To give you an idea of the data, this is EM2040 bathymetry of a pipe, and then we have the photograph taken at the very same time that the vehicle was going over that point. So a comment was made yesterday that AUVs will survey at 6 or 8 knots. A pipe survey of this kind of altitude, very low altitude, will run at maybe 3 to 4 knots. So you're going to be 6 or 7 or 8 times faster than an ROV, collecting almost the same data set. There are some things that we still can't do. We can't do cathodic protection assessment of pipes, but that may come with in situ sensors in the near future. Now, for the military customers or the military operators in the room, there's something that's brand new for you. So until recently, I mentioned earlier, AUVs have been able to detect, sometimes classify mines or mine-like objects. We recently delivered a system to a European Navy that is equipped with the latest version of HISAS, which has in-mission processing of the data and adaptive mission planning. So the SAS collects the data, and you can see here we've got some mine-like objects that kind of look like cylinders. Now, are they mines? Are they CO2 bottles? What are they? We don't really know. All we know is they're mine-like objects. So HISAS is processed in real time, and then an automatic target recognition algorithm picks out the highest priority images. It then feeds it back into the vehicle controller, and the vehicle controller will look at how much energy it's got left and where it is and where these targets are, and it will automatically plan a mission to go back and photograph every single one of those targets. So in a single dive, autonomously, without any interaction from an operator, we now have detection, classification, and identification. This really is the state of the art for AUVs out there right now. This is as good as it gets today. Intelligent robots you can rely on, you can count on. Reliability is very, very important to us. Commercially, we wouldn't have sold as many and done as much if they didn't work. So we have commercial operators who tell us their reliability figures. We have military operators who don't because it's sensitive information. So commercially, DOF Subsea operates a Hugin 1000 model and has publicly declared better than 96% serviceability and availability of their asset. Fugro in December publicly declared a success and availability and serviceability rate of 98.15% on Echo Surveyor 6. We delivered that to them in July, and by the end of December, it had completed 61 back-to-back missions in Azerbaijan, in the Caspian. And each one of those missions was 48 hours long. They recovered the vehicle, they put it on the deck, they downloaded the data, they swapped the batteries, they put the vehicle back in the water within 2 hours and did another mission 60 times. Unbelievable reliability. So the contact details are here on the presentation for everybody to see. If anybody has any questions, I'll be more than happy to answer them in the panel, or alternatively, just come and grab me. I'm a fairly memorable guy. I think I'm the tallest guy in the country with Peter at the moment, so come and grab me and I'll answer any questions that you have. Thank you very much indeed.